Right, so we're somewhat depleted, but not as depleted as I was expecting us to be at this stage of the conference. So thanks for hanging around. And in the words of Monty Python, now for something completely different. So what we want to do, so storylines has cropped up a number of times through this conference, and a number of us have been working on storyline type approaches, but we tend to mean slightly different things by them. So I'm going to call co-conspirators of John, Andy and Hazel sort of involved in thinking around storylines. What I want to do... Hello. What we want to do this afternoon in this last session is break out into little groups and go away and discuss and try and formulate some storylines around certain themes, and then come back and just give a little bit of feedback later. But the idea is simply to play around with what storylines mean and try and create some from different perspectives. What's wrong?
Apparently we're muted, so people cannot hear us.
Okay.
I would say that's a bit...
Okay. So in thinking about doing that, it seemed important to say something about what we mean by storylines. And as I said before, I think there are lots of different definitions, lots of different approaches. So I'm just going to give you mine. So what I'm going to do is spend 10 minutes or so talking about what I see as a storyline and why they're valuable, and then laying out kind of what I want you to do. So we have 10, 15 minutes at most, and then I want you to break into groups and go out. So from my interest in storylines kind of began, so this paper is from 2015, so it'll probably be in 2013 or so, when we had a meeting at KNMI, and Wilke Hazelega and these other authors and a number of other people got together trying to work out how do we provide information to, in Andy's terms, users. So people out there in society who are wanting to adapt or prepare or understand what the future is going to be like under climate change, what sort of information should we be providing them with? And at that meeting, we had quite a lively debate about that. And in particular, there was a lot of focus on the reliability, or in particular, the lack of reliability of Earth system models in providing that sort of information. So the sort of information I'm talking about is sort of regionally specific, perhaps local, to do with particular variables that are going to impact whether you're going to flood, whether the factory's efficiency is going to change, this sort of detail. And we felt that the models were not up to that, and indeed that's been a pervading concept through most of my career before and after. But at this meeting, we talked about that a lot and said the models aren't up to this, and kind of got round to, okay, so what do we do? If we can't use our models, what do we do? And we had a lot of discussion about that, and we came up with various thoughts, which led to this paper called Tales of Future Weather, which Hazelega et al. 2015. And that has a number of ideas within it. But crucial to today and crucial to my perspective was that what we should be doing is we should be extracting robust understanding, process understanding, the things that we would know about the climate system. And we should be using those to create stories, storylines, narratives, tales, it's gone through many different terminologies, about how the future as a whole could pan out, and in particular how the future in a particular region or for particular variables could pan out, irrespective of the models. Now, of course, the models feed into our understanding, so they're not irrelevant there. And one of the arguments was also that the models could be used, particularly weather forecasting models, well-calibrated models, at least to the current day, could be used to fill in details of quite what the future would look like in a particular place, but driven by some sort of storyline of quite how the wider climate would unfold. So that was my introduction to storylines coming out of that. And the crucial point here is that from my perspective here, storylines are not simply a communication tool, although they are useful for that. And they're certainly not simply a tool for describing the behaviours in models, but rather what we should be using them for is to embrace uncertainty. So we're trying to go back to processes and say, what is the basic understanding we have of the physical science and of the social sciences, and how can we use that to explore what could happen in the future, and in particular, well, beyond what is happening in our models. So our models do certain things, that's fine, but it is quite possible to draw up other scenarios of quite what would happen that are consistent with our understanding of the processes that happen in the climate system. So we want to go beyond the models. The crux here is that for those users, the most useful thing, I think, for wider society is to have a good understanding of what the future could look like, conditioned on our understanding of the physical system and indeed the social system today. And that's different from what our models show. So it's about trying to bring together as much understanding as we can to explore the different types of uncertainty that we might be experiencing. Okay, so that was what we sort of came up with in 2015. What that led for me was to go away and do other things mostly, but somewhat go away and ultimately we ended up doing a piece of work with people in Leeds, Suraj Desai and others, which was something of an example of this sort of approach. So the idea here was saying, okay, what are we interested in? In this case, we're interested in supporting decision makers involved in water policy in southern India. That was our project. That's what was funded. That's what we were trying to do. So we're asking ourselves, well, okay, how do we do that? What is going to happen to water resources in southern India? And in particular, what that comes down to is what's going to happen to the Indian summer monsoon, both in its character, in its patterns, in its intensity. And so what we did was we got a group of monsoon specialists together in London. We were fortunate that they were happening. They happened to be there in any case, and we grabbed them all for a day in LSE. And we asked them how the Indian summer monsoon could change. And it was a really interesting discussion. It was a whole day, but I would say half of that day we spent saying, how could the Indian summer monsoon change? And they would come back and say, well, our models show that this will happen, or this could happen, and this can happen, and this can happen. And we'd say, okay, but what do you think could happen? And they would go to a different model and say, okay, this other model shows this and this. They would anchor everything to their models. And it took us 3 to 4 hours before we were able to tie them down and say, we want to go beyond what the models show. We want you to think about what are the processes that are involved in the Indian summer monsoon and how they could change. But they did that in the end, and they came up with, and we don't need to go through it, but essentially they came up a number of key processes down here that will influence the intensity and the character of the Indian summer monsoon. And they came up with different sorts of responses that you might get. In this case, we're talking about decreasing or increasing flow, essentially the winds across the Arabian Sea there, and decreasing or increasing moisture availability. Most of the models will be up in the top right-hand corner there, I believe. And I think we left the room thinking what the models show is probably the most likely behaviour, but there was a sense that there are other combinations of processes that could lead to quite different outcomes, if only for some decades, 30, 40, 50 years. So, we kind of felt that what is shown in the models will dominate in the longer term, but for 30, 40, 50 years, you could get something doing almost the exact opposite. And in terms of informing those users, that was a crucial thing. So we had a couple of papers, one out of the expert elicitation and the other one actually talking about these results with decision makers in Karnataka in southern India. So I present that as a sort of, that's kind of where I'm coming from. I'm coming from trying to explore those domains of possibility, those ranges of behavior. So what I want you to do, I want you to break up into groups of 6 to 10 people in a group, and I want you to go away and have informal discussions. I think we've still got the rooms that we've had for the whole conference, but you know, the space outside, there's the other room we've got. According to the booking sheet at the front of the building, it says that we've got these rooms until 6. So you can go and find these other rooms. Just find somewhere, sit down and discuss, and then come back. And if you could nominate someone to give some sort of feedback, that might be nice. But the main activity is to do it. I've said come back to 16:45 because I thought we were on the other timetable. So we want 17:15. So come back at 15:15, for 3/4 of an hour. Yeah? Is that good? Does that work? When do you want to close? We don't even need to, yeah. Let's do 5:10. Shall I finish, Kwat, or do you want to? Okay, so what I want you to do is pick a question. So I'm giving 3 example questions here. So, for instance, what are the combinations? So there's 2 stages. Stage 1. Stage 1 says, what are the different combinations of processes that could lead to an 80% reduction in AMOC by 2100? Or maybe you're not working on AMOC. So what are the different combinations of processes that could lead to an 80% Amazon deforestation by 2070? Or what are the different combinations of processes that could lead to some specific and sustained change in the subpolar gyre by 2090? Whatever the question, wanted to create storylines that lead to this change. And yeah, these should, if at all possible, go beyond what we see in the models. These examples of questions are not fixed in stone. Don't get obsessed by these particular questions. What is important here is to have something specific and with a specific time frame. And what we want is to explore the different processes that lead to that could lead to that change. So that's stage 1, but this isn't giving a range of behavior. The stage 2 is say, okay, for the question you chose in stage 1, choose a particular region. So it could be Northern Europe, Western Europe, Eastern US, the Mediterranean basin, other places around the world, and choose 1 or possibly more, but we haven't got much time, variables that would be interesting to look at. So that could be regional mean temperature, annual mean, regional mean temperature, or regional mean precipitation, or perhaps crop yields for some specific crop, but we're wanting to make that specific, or extinction risks, ecosystem changes and the like. For those of you in ClimTip, when within ClimTip there's an element of looking at the economics of the consequences of tipping points, and that takes us into a world where we're looking at economic damages which tend to be related to regional mean temperature change. So this is where I'm coming from here. When I'm thinking about regional mean temperature change, I'm interested in that because I can use that to translate into economic damages, at least if you believe the economics at the moment. But let's not worry about that. So it's a useful variable, even though it's also probably one of the more predictable variables, so it's valuable there. So we're choosing a region and we're choosing a variable, and we're constructing physical storylines for the largest and smallest possible change in that variable in response to the chosen tipping point. So, stage 1, choose your tipping point. In many ways, what was it? And think about the processes that could lead to it. No. I was aware that I should have put this somewhere so that you could reference it, but there you go. And stage 2 is saying, okay, what are the consequences of that tipping, however defined, but it has to be precisely defined. And what is the range of uncertainty in the response to that tipping, and how would those come about? So in many ways, you can ditch stage 1, unless you're interested in it. Go straight to stage 2, say, you've chosen a tipping point, you've chosen a degree of change, you've chosen a time frame, and you're saying, and you're now going to say, what are the different ways that that can influence some user-relevant variable? And you've chosen a user-relevant variable, so it's all focused down and saying, right, I'm looking at Northern European regional mean temperature, boom. I'm looking at some definition of SPG tipping, boom. How big or small could the change in my variable be? And what would be the processes that lead to a large change or a small change? Okay? Does that make sense? It's a lot to do. It's sort of solve the climate change problem. You've got 35 minutes starting. Did you get the one in between, Andy? Because it's that one that's the most crucial one. I'm going to leave this one there.
Can we upload this to the drive? I'll just put it in the drive.
Yes. Yes.
Like, if you're okay with that.
I'm fine with it. I'm fine with that. I'm just not sure I immediately know. But yeah, absolutely. Yeah. So you can put that in the drive. Okay. I would perhaps also say, I hope that John and Andy and Hazel at least know what I've tried to ask for. Andy's looking sheepish about that. So go to them if you're unclear quite how what you're meant to be doing. And success is that you've had a good conversation. Yeah, Andy? One moment. Yeah, wait 1 moment. And
So I've got a question. So do you want us to think, how we write it? Like, even in what person do we write it? Do we write it in the first person or the third person? Do we write it as like, I'm an Indian farmer?
No. You're a scientist. So this is you're a scientist. You are interested in that farmer, but you are a scientist and you are trying to create different lines of argument for how this variable that you think is relevant to the farmer could change in response to a tipping. And my hope is that there will be different people in your group who would throw up different lines of process changes to yourself so that you get so that you can debate quite how those can combine to influence the end user. But this is not from the point of view of the end user, it's your point of view as scientists, but to inform the end user. Yeah?
I guess that you probably should have the same story, but you probably should have in different language to different audience.
This is about quantifying uncertainty. This is about trying to get the widest range. So it's not about the language, it's about the processes. It's about taking processes that you think you understand and how they could combine in ways that maybe are not represented in the models. Maybe you think the models are going to be, maybe you come to the conclusions that the models actually explore all the uncertainty you need, in which case we can have another very lively debate. But the idea is not. Okay?